Lesson 35 outlined here. We only got 3 things to talk about, and all of them are related to this whole idea of change in coordinates. If you can remember anything from this lesson, you will take from it that it's always final minus initial. And final minus initial takes on many different forms, because we could be talking about the x's or the y's, and we could be talking about from point 1 to point 2, or from point 2 to point 1. It changes. Now here's the cool thing, and we've talked about this before, that if I'm at home and I travel to school, that's 6 miles. If I'm at school and I travel home, it's still 6 miles. But the perspective changes. And so therefore, one of those, in the grand scheme of things, if I'm talking about how far from home I traveled, if I was at home, went to school, and went back home, I went a grand scheme of 0 miles from home. Or my displacement, we'll say, displacement I think is a better word, my displacement from home would be 0 again, right? Because from home to school, yes, I covered 6 miles. My displacement is 6 miles. But as soon as I went back home, it zeroes itself out because one of them is a forward way and the other one's a backwards way. So therefore, it's a positive and negative of that 6, which cancels each other out. That's what's going to happen here. As I travel from point 1 to point 2, or from point 2 to point 1, both in my x's and my y's, their differences for my x's will be the same no matter which point I'm coming from. It's just that one of them will be negative and the other one will be positive. Same thing for the y's. So let's take a look here. I have point 1 and point 2 there. So to make it easier, because I was having a little trouble with the last hour on this one, is x1, y1. Would you guys agree with that? The other point would have to be called
x2, y2.
x2, y2. We're going to make this easier for ourselves. And remember, it's always final minus initial. And so if I look at the first one over here on the right, x1 minus x2, that would be the final minus the initial. Where am I starting? What would be my starting point if I wanted to find that change in coordinates with those numbers, or those x values? I would start at which point? Point 1 or point 2? Point 2, this one would be point 2 on my way to point 1. Can you guys see that? Why is it point 2 to point 1? Because point 2 is my initial, and I'm going to travel to point 1. That would be in this direction, yes? But I'm not talking about the point itself, I'm talking about which coordinate? The x's, right? X's only go which way? Left and right. So I'm actually going from the right point to the left point. And if anything, if I take that one line out, it would travel more in that direction. Would you guys agree? Because that is taking me from point 2 to point 1's x value. Point x1, right here. What is that change? Now, wait a minute. Let's think. If I'm starting to the right, and I'm going to the left in the x direction, which way am I going? Negative. So my answer will be negative. Does that kind of make sense? That if I'm going in the negative direction of x, my answer, the change, has to be going negative?
Wait, what if it's like a different slope?
We're not worrying about right now about the slope or the slope of that line. It could be going the other way, particularly. But if I'm going from point 2 to point 1, so I'm starting here and want to end up here, I will have a change in my x coordinates that's going backwards. So watch what happens. What is x1? It's negative 7. What is x1?
X2?
I mean x2, sorry, minus x2. I looked at this one underneath.
3.
It's 3. And what's negative 7 minus 3? It's negative 10. So what is the change in coordinates, by x coordinates, from point 2 to point 1? It's negative 10. So I'm actually going 10 steps backwards. Wait a minute, what if I reverse that? What if I said I'm going from point 1 to point 2? I'm going to change the color to red. But wouldn't that mean I'm going this way in the red? That means now I have a final point of x2 and an initial point of x1. But switch their roles. What's x2? 3 minus what? Negative 7. When you subtract a negative, you are adding. That's a bad 7. So that ends up being 10. So if I actually went from point 1 in the direction of point 2 in the x's, I'm going to positive 10. Does that kind of make sense there? I was going to say make change. So we're talking about change. Does that make sense that if I'm going from a left point to a right point, my x's have to be getting larger? Or that change is a positive change? It all depends on where you're coming from to where you're going. Take a look at my y's. If I say y1 minus y2, what point am I starting at and which where am I going to? y2 should be my initial point, right? Because the initial is always the second one. So I'm actually going from point 2 on the way to point 1. It's always kind of like the reverse order of those subletters. I'm going from point 2 to point 1. Wait a minute. Point 2 is here, and I'm going to here. That means I'm going in a positive direction. That means the change will be positive. It's one way for us to check if we're doing something right. What is y1? y1 is 4 minus a negative 2, which makes positive. So therefore, 4 plus 2 is 6. And that's what we thought. Now, if I switch it around, now my final point is y2 while my initial is y1. That means I'm starting at point 1 and traveling to point 2. It means I go down. So that'd be negative 2 minus 4, which is negative 6. You notice, again, they are the same value, but one of them is a positive change and the other one's a negative change. So the problems I'm going to ask you now is I'm going to give you these changes. I want you to tell me, is it a change in x or is it a change in y? And are we going from point 1 to point 2 or point 2 to point 1? Can I change? Here we go. I have 4 problems on the board. The first one, part A, deals with the point 1 being negative 3, 2. Point 2 being negative 4, negative 5. What does the change from negative 3 minus negative 4 represent? Which variable and what is my direction? So negative 3 and negative 4 are what letter? X or Y's? It's X's. So I am going to use this thing. What does that mean? Now, what's that triangle mean? Delta. What does delta mean? Change in. You guys remember seeing that in your science classes? Actually, when you first learned slope, you may have seen delta x or delta y over delta x, which is a change in y over the change in x. That's a change in x's. We know we're going to deal with change in x from, so I'm going to put from, point what to point what. Well, maybe it might be easier to recognize that, hey, this is final minus initial. Yes? Initial would be my starting point to my final point. If the I is negative 4 is in which? That negative 4 is in point 2. So I'm going from point 2 on my way to point 1. So point 2, arrow to point 1. The second one is a negative 5 and 2. Which one is a negative 5 and 2? It's the y's. So we're going to say that it's a change in y from 2 is my initial point. 2 comes from point 1. So if I start at point 1 and head towards point 2, I will have a change in y's that looks like negative 5 minus 2. Right? Or has a value of that. I'm not asking you to find that value. I want to know which variable and from where to where. Pretty logical. Takes a little bit of thinking. Make sure you have it right. But once you have it right, you're good to go. So, what about A on the next one? We have point 1 is negative 3, negative 2. Point 2 is negative 4, negative 5. Now everything's negative. Oh, does that mean anything? No. We still can have a positive change if we're going from the smaller number to the larger number, and a negative one if I go the other way. But which one has a negative 4 and a negative 3? That would be my x's from final minus the initial. So negative 3 is my initial, which is point 1, on my way to point 2. Not too bad. And the last one, negative 2 and negative 5. That'd definitely be a change in y's, yes. From negative 5, which is over here, so point 2 to point 1. So remember, we have number equals initial plus the fraction times our change, our delta C. And remember, delta C was our final minus initial. So if I have negative 7 on the left and 3 on the right, I am following the number line from smallest to largest numbers. Which way am I going again? Which direction? On this number line, would I have to be going? I'm starting here and I'm going this way, right? According to that problem, do I make it all the way? No, I only make how far? 2/3 of that way. So to find out what 2/3 of the way is, I need to find the total distance, right?
Yeah.
And that total distance goes back to initial and a final, or final minus the initial. If I took what it is from negative 7 and 3, that total distance, I can multiply that by 2/3 and go from there. And that's what we're going to do. Wait a minute. Final minus initial. What's my final number? Negative 7 minus 3, which equals negative 10. The change in your coordinates, that's why they're using C, coordinates, is negative 10. That means I'm going in the backwards direction. Does that make sense? Is that what I'm doing? I'm starting with a positive or a bigger number, going smaller. So my new number, I'm going to jump on the bottom here, my new number is just the initial starting point, 3, plus the fraction times negative 10. The fractional, how much of it's actually being used, 2/3 of that distance, times negative 10. And I just had to put it all together. Keep it as an improper fraction if it comes out to a fraction. What's 2/3 times negative 10? It's minus 20/3. You probably should get a common denominator, and the common denominator would be 3. But what I do to the bottom, I have to do to the... So I get 9/3 minus 20/3. And I think everyone should understand what that would be. Negative 11 over 3. So negative 11 over 3 would be where you would be on the number line or your new number. That's how far I got. I got to a negative 11/3. Now let's think about this. If the total distance was 10 or negative 10, and I start at 3 and I'm going to the left, 2/3 of that whole distance would have to push me into the negative numbers, right? So that should make about some sense. Plus, what's a third of 10? A 3 1/3. And I have to go 2 of those. So therefore, I should be a little bit past 3. That should make sense. 3 2/3? Or negative 3 2/3? So keep that improper, that's your new number, negative 11/3. Any questions? What about these two? They get a little bit progressively harder, at least the last one is a little harder than the first one here. No. So, we got to find that delta C. Delta C is final minus the initial, which is? So I'm going from negative 4 to 9. The change will be what? Positive? Because my final point is 9, so where I'm stopping, minus where I started, which is a negative 4, which you subtract a negative, you are adding. So we know that the change overall will be a 13. Do I get to actually travel all 13 though? No. I'm only traveling how much of it? 3 over 7 or 3/7. So my new number is, where's my initial? Negative 4 plus 3/7 times 13. Can I make that 13 over 1?
Yes, it's still 13.
Still 13. Why would that be advantageous to myself here? Because I'm going to have to do multiply it by a fraction. And how do we multiply fractions again? You multiply across. What's 3 times 13? Over. Got to have a common denominator of 7. So we get a negative 28 over 7 plus 39 over 7, which is 11 over 7. So where am I standing if I end up going 3/7 of the way from negative 4 to 9? 11/7, or just over 1.5. Okay? Last one of this type. Find delta C. I'm going from 3 1/8 to negative 3 5/8. So that means my change will be negative because I'm going smaller. I don't like those. Let's convert those to improper fractions. How do I convert to improper fractions from mixed? You take the whole number times the denominator and add the numerator and then place that over the denominator. So what's 3 times 8? 24 over 8 plus 1, right? So 25 over 8. 3 times 8, plus 5. 29 over 8. And that's negative. So what's the final? Negative 29 over 8 minus 25 over 8. Ooh, what do we get here? Negative 54 over 8. Hey, I could probably reduce that a little bit. Might make it easier for us. What would that reduce to? 27 over 8, and that would be negative, yes? Okay. So my new number is, where am I starting again? 25 over 8? Plus? Oh, it is over 4, you're right. So it's our initial point plus the fraction, which is 5/11 times the difference. Negative 27 over 4. What is 5 times 27? So we get negative, or 25, sorry, over 8 plus, or let's just say minus, 105 over 135? Uh-oh. Sounds about right from last hour. I can't just put those together, can I? No, I need to have a common denominator again. That doesn't look nice at all. What numbers does 44 and 8 both go into? 11? No.
Just kidding.
88. So 11 and 11. And this one is 2 and 2. What's 11 times 25? Or if you have 11 quarters, how much money do you have? 275 over 88 minus 270 over 88. And hey, that turns out to be 5 over 88. So, I still am on the positive side of 0, even though I'm traveling 5/11 of the way from 3 1/8 to negative 3 5/8. Boom. We're done. So some of us may have already done or used the distance formula before. We're going to quickly just build it using that whole idea of final minus initial. So, to make it look like the bottom one, and it doesn't matter, because distance itself is always what? Positive. So it would not matter if I went from point 1 to point 2 or from point 2 to point 1, correct? So what I'm going to do is I'm saying I want to make it from point 1 to point 2. Final minus the initial. Okay? But here's the thing. I got to get there. And wait a minute. How are we going to get there? We're going to get there using Pythagorean's theorem. Because we do know that special theorem that says if I take the sides of a right triangle, square them, add them, it equals the square of the diagonal, which we will call d for distance. We've done this many times before. So the question is, what is this point? What is the point at the intersection of, or at the 90 degree? What would that point be? And no, it's not x3, y3. It's made up of the other two. Let's think of it this way. if I have a vertical line like I have here, all x values are the same. What is the x values of this line? It's x2. Interesting. So it's x2. All y values have the same y value on a horizontal line. So they are all y1. And so, how can I figure out the distance between those points if I say that I am still going to start here at my initial point, guys, and I am going to walk over this way? So at this point, I'm going to call that final right now. What's the coordinate going horizontally? What's the only thing that changes going horizontally? X. So what is my change in x's here? From the initial to final. I don't think it's x1 first. If I start here and I walk this way, what's the change in x's? It's x2, my final, minus the initial. x2 minus x1. Can you guys see that? That's my change in x's from those points. Now we have to say, wait a minute, wait. Now I'm standing here. And I want to get to here. So I can end where I want to end. So this final down here from the first leg actually turns into the initial on my second journey. If you take a look at it as legs of a journey, where I stopped is where I pick up again and walk. So now, if I wanted to know this leg, what is the change in coordinates of that leg? It's y2 minus y1. Because my final point is y2 minus the y1. Right? So wait a minute. If I want to use this formula, A and B stand for the legs, yes? So you're saying that x2 minus x1 squared plus y2 minus y1 squared will equal the hypotenuse squared, which is D. That's what we're just plugging A and B and C into our formula, all right? Or our difference, our changes into that formula. And then to solve for D, I just take so D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that, guys, is the equation right there. What I will tell you is it doesn't matter if it's x1 minus x2 and y1 minus y2. Because that difference, even though we showed in our first slide, one's positive and one's negative, right? We're doing what to it at the end here? We're squaring it. And when you square a positive or a negative, it turns positive. That's why it does not matter. So, the very last thing we need to do then is, wait a minute, give me an expression that tells me the distance from a point we know at 4, -2, and some other point we're going to call xy. We don't know what it is. It's xy. Here's the cool thing. All you have to do is tell me which one you want to call point 1, which one you want to call point 2. Which one's point 1? 4, -2. So this would be x1, y1. Then the other one would be x2, y2. And plug it formula. And wait a minute, what was that formula? D equals x2 minus x1 squared plus y2 minus y1 squared. Yes? What's x2? x2 was x. So x minus 4 squared plus, what's y2? Minus a negative 2 squared. But if you subtract a negative, you are adding. There's your problem. That's an expression. You're done. Done. D-U-N. Your homework for tonight is page 253, 4 through 8, 21, and 22. Have a great day.